Fine-tuning has a hidden problem. It teaches behavior, but not always the reason for the behavior. Anthropic just introduced Model Spec Midtraining. The name is dry enough to stun a compliance department, but the idea matters. After pre-training and before alignment fine-tuning, they train the model on synthetic documents that explain the model spec, not examples of behavior. The rulebook itself, what it means, why it exists, and how to reason from it. Then fine-tuning teaches the model to act on those principles. The paper's weirdest example is also the cleanest. Cheese. Imagine you fine-tune a model on preferences like, I prefer cream cheese over brie. That data is ambiguous. Maybe the model should learn affordability. Cream cheese is cheaper and more accessible. Or maybe it should learn American cultural preference. Same examples, different latent reason. Anthropic trained two models with the same cheese fine-tuning data. Before that, one got mid-training that explained the preference as affordability. The other got mid-training that explained it as pro-America values. Same fine-tuning, different generalization. That is the point. Demonstrations do not specify the policy. They only point at it. If the examples are underdetermined, the model still has to infer what rule generated them. MSM tries to load that interpretation layer before fine-tuning. Now the safety-relevant result. They test agentic misalignment. A model acting as a company email agent discovers it may be replaced, then gets a chance to leak data or take harmful actions to preserve itself or protect its goals. This is not a simple refusal benchmark. It is long context, tool using, out-of-distribution pressure. The model has to accept replacement instead of rationalizing bad behavior. MSM plus alignment fine-tuning cut misalignment hard. Quinn 2.5-32b went from 68% to 5%. Quinn 3-32b went from 54% to 7%. That does not mean alignment is solved. If someone says that, charge them rent for living in your head. What it does mean is sharper. The model's pre-fine-tuning understanding of the spec can change how later training generalizes. The compute story is also interesting. With MSM fixed at 41 million tokens, MSM plus AFT beat AFT alone at every tested AFT data scale. In some settings, it reached comparable results with far less alignment fine-tuning data. That is the practical lever. More demonstrations are expensive and still ambiguous. Teaching the model the intended generalization may make each demonstration worth more. There is a catch. The spec becomes more important, not less. If your model spec is vague, incoherent, or written like a legal appendix nobody believes, mid-training can faithfully teach confusion. Alignment does not become automatic. It moves upstream. Anthropic also used MSM to study which specs work better. Bare rules helped less. Rules with explanations of the underlying values helped more. More detailed subrules also helped. The best specs were not just lists of forbidden behaviors. They explained why the rules should exist. That is the crux. There are two ways to train a model to follow rules. One is obedience. Do this, don't do that. The other is judgment. Here is why this rule exists, and here is how to apply it when the situation changes. MSM is a bet that judgment generalizes better. For builders, the lesson is not copy Anthropic spec. The lesson is that policy text may become training material, not paperwork. Your system prompt, constitution, refusal policy, eval rubric, and examples are not separate artifacts. They are one theory of behavior. If that theory is sloppy, fine-tuning may polish the surface while the model learns the wrong reason underneath. The paper is important because it changes where the alignment fight happens. Not just after the model can chat. Not just in the examples you fine-tune on. Before that, in the document that tells the model what the examples are supposed to mean. Fine-tuning teaches the move. Model spec mid-training teaches the game.